that why in case of phenol, the cleavage of carbon-oxygen bond does not occur under ordinary condition. Why? Because the carbon-oxygen bond in phenol is having partial double bond character. Okay, so just like alcohol, you can substitute OH group. In phenol, it is not easy to substitute the OH group. Okay, now, but still, under drastic condition, this can happen. See, it happens with us also. Tell me, how many of you like to read chemistry in your off time? Suppose now though you are having lockdown. I think you have locked down your book also. So in that case, how many of you like to read chemistry book in your leisure period? Just like the phenol. But when the exam comes, you read it for hours together. This is called drastic condition. In case of phenol also, such thing occurs. So if you subject phenol at very high temperature in presence of catalyst, in that case you will find phenol also undergo substitution of OH group. Okay, so please remember that however under drastic condition, the substitution can, OH group of substitution of phenol can occur. Under drastic condition. So what is under drastic conditions? High temperature. Okay, high temperature. So in your house also, what is the high temperature? Shouting of your parents. Pressure, continuously mother is talking. Okay, remember, high temperature, high pressure. And catalyst. What is the catalyst? Exam routine. So everything happens in our life. The OH group of phenols can be substituted. Bolo, jolai gise. So one, what is that? Reaction with zinc. This is there in your book. Reaction with zinc. When phenols are distilled over zinc dust, comma, dehydroxylation means which group goes out. Dehydroxylation takes place. Okay, now suppose this is the phenol I have taken. This is phenol, and this is zinc. I'll write here. Distill means what? The solid substance when you distill, high temperature is there. So see here, OH group gone, and you get here zinc oxide. Means what? Carbon oxygen bond also breaks, oxygen hydrogen bond also breaks. Hydrogen comes in this place, and you get this one. This is there in your book. But anyway, I will give you another reaction. Okay, I'll write here now. Replacement by ammonia. Please do not remember, this is one of the industrial preparation of aniline. Okay, so if you take phenol and if you react with ammonia, okay. So if you heat it with zinc chloride at 573 Kelvin, means 300 degrees Celsius, you get here aniline. This is the industrial preparation of aniline, which is huge amount we require to prepare different types of dyes. Okay, clear? So now I'll go to the third category. What is the third category? That is electrophilic substitution on benzene ring. We have classified these properties of phenol into three categories. Remember, one is the acidic property of phenol. There we have read about plenty of reactions. Then second is the nucleophilic substitution of OH group. Okay, that is also finished. Now we'll go for the electrophilic substitutions. Electrophilic, this is C. Electrophilic substitution. Okay. Please remember, OH group, oxygen has a lone pair. So OH group is an electron donating group, and it increases the density of electron at ortho and para position of phenol. And so electrophilic substitution takes place there. So we'll write OH group, see here, two lone pairs. Group is an electron donating group. Perfect. And it enhances the electron density at ortho and para position of phenol. Hence, electrophilic substitutions occur at both the positions, But if I tell you, why should you believe me? Okay, I'm not a god. Then whatever I say, I have to believe closing my eyes. So in that case, we have to see, because this is science. Science, every word can be questioned. Okay, you can ask. In English, you will ask why, and in Khasi, what you will say? What is the word for Khasi? Why? Hey, is any Khasi student here? Hello? Not a single one is replying. Huh?
Yes, sir.
What do you say? Why?
So what's the word?
What is the Khasi word for why? W-H-Y.
Ballet.
Ballet. Yes, you should say ballet. But you never ask. I found only this Eugenia only speaks. Others are what happened? They become voiceless or what? See here. Which are the places you are having negative charge? ortho, para, and ortho. So in these places only electrophilic substitutions will occur. So what will be the hybrid? Hybrid will be this one. All these things you should know. Okay, nobody should tell that my students are foolish. People should say, they're so intelligent like this. See here. So these are the three positions where the electrophilic substitutions occur. Please write down. Write down in 2 minutes. This one. I know later on you will not remember. Right from here up to this much. The question may be asked. Why is substitutions occur ortho and para position? Right. 2 minutes. Written. I have not talked to Aishman for a long time. Aishman? Hello? Aishman? Aishman is there or not?
He's not there.
What happened? He has discontinued or what?
I don't know.
Okay, just if you know his phone number, call him.
Okay.
Finish?
Yes, sir.
Okay. Then we'll do the examples. Write down examples. Now we'll do bromination. Okay. There are two conditions. Bromination of phenol in non-polar solvents like this is called carbon disulfide or carbon tetrachloride gives a mixture of ortho and para bromo phenol. Okay, so This is phenol. This is bromine. Carbon disulfide. In your book, carbon disulfide is given. CCl4 is not given. Your book is very few. Okay. So you will get here. This is called orthobromo or 2-bromophenol, and you will get here para-bromophenol. See, bromine is a large atom. Okay. In this case, it will have some obstruction for space. So this will be major. This is orthobromo, bromophenol, and this is para-bromophenol. This is major. Okay. B. Bromination of phenol in water gives 2,4,6 tribromo phenol. Okay? It will immediately give at room temperature. This is phenol. Please remember 3. Here it is water. So you'll get here. You get this one. You get this. This is called 2,4,6 tribromophenol. 2,4,6 tribromophenol. Okay? Then we'll go for nitration. Nitration also can be done under 2 different conditions. Okay? So, we'll write here now. Nitration of phenol with dilute HNO3. Remember, the nitration is always carried out with concentrated nitric acid and sulfuric acid. But here phenol is so reactive, you do not require sulfuric acid. With dilute nitric acid, only nitration occurs. To form a mixture of ortho and para nitrophenol. Okay, so we'll write here now HNO3. Here I'll write water, means dilute. Okay, this is orthonitrophenol. This is para-nitrophenol. This is orthonitrophenol. This is para-nitrophenol. This is also measured in amount. Okay, now after that, now from this mixture, how will you separate them? This is important for exam also. Okay, it is
separation of mixture of ortho and para nitrophenol. Separation of mixture of ortho and para nitrophenol. Okay? So I'll write down first, then after that I'll explain. See here. Para nitrophenol I'll draw. This is important for exam. This is the structure of nitro. Hydrogen bonding is there. This is paradictrophenol. And then I told you how does this optimizer look like. See here. Here you are having intermolecular hydrogen bonding. Here you have intramolecular hydrogen bonding. Okay, so that's big. Can you see? Intramolecular hydrogen bonding. And here you have intermolecular hydrogen bonding. Okay? So from here to here, please write. After that, I'll explain. Please, from here to here. Please write. It's important. না না দিয়ে দিই কারণ দেখো ড্রামের জল নিয়ে আমরা বাথরুমেও হাত করতে পারি, কিন্তু বাথরুমের জল দিয়ে তো আমরা রান্নাঘরে হাত করি না। রাখো তুমি জল থেকে পেঁচাইতাম না গো, এমনি হলে রাখা যায় না। আমার হলে আমার পাইপ ভাঙ্গে, আমি পেঁচাইছি নাকি? এই জলটা নিয়ে পরে এখান থেকে উঠে যখন প্রথম যে চিপাচিপি খায় তখন একটু ময়লা। না না এটা ময়লা তো, তখন ময়লা আছে। Writing finished? Hello?
Done, sir.
Acha, now you write. Right. The mixture of orthonitrophenol. For ortho, you write only O. The mixture of orthonitrophenol and paranitrophenol is separated by steam distillation. Separated by steam distillation. Full stop. Okay? So now, right. This is because, right. Paranitrophenol molecules are associated with each other through very strong intermolecular hydrogen bonding and has high boiling point. Done. Full stop, right then. Right. After full stop, you write. On the other hand, orthonitrophenol exists as.
Pardon, sir.
On the other hand, orthonitrophenol exists as individual molecules due to intramolecular hydrogen bonding as a result has low boiling point and is steam volatile and is steam volatile. Now, first of all, let us know what is steam volatile. Have you seen any substance which is steam volatile? Hello? Have you seen any substance which is steam volatile?
It's
Huh?
steam volatile or steam volatile.
Have you seen any substance steam volatile? See, in your kitchen, why do you find the wall of the kitchen is sticky? Because when you cook along with the water vapor, the well that you have used for cooking, does it not come along with that? So all types of wells are steam volatile. Now see why this boiling point of this one is higher. See here, any substance which you boil it goes to the vapor state as individual molecules. When you want to boil this one, all the hydrogen bonding it has to break. So it requires more energy. More energy means more heat. More heat means more boiling point. But see here, orthonitrophenol are not associated with other molecules. They remain individual molecule. So moment you heat it, it starts coming out from there. So we separate by steam distillation. Okay. Now we'll go for the second method, second nitration. Okay. Second nitration is that if you do with the normal condition. What is the normal condition? Nitration of phenol with a mixture of concentrated HNO3 and concentrated H2SO4 at higher temperature gives 2,4,6 trinitrophenol. Trinitrophenol. Okay. So what should I write? We'll write like this. Phenol plus 3 HNO3 concentrated. Now we'll take here concentrated H2SO4. Okay. And we have to heat it. After that, what you'll get? You'll get here 2, 4, 6 trinitrophenol. Okay, you'll get here 2, 4, 6 trinitrophenol. 2, 4, 6 trinitrophenol. It is extremely acidic, that I told you. Okay, so its common name is picric acid. Picric acid. She is little explosive in nature. Huh? Any compound which contains lot of nitrogen are explosive. But anyway, you will not die because of this explosion. This is being used for dyeing of cloths. It is being used to dye silk and wool. Okay. It is pale yellow in color. Please remember, this dye is moth resistant. Moth, M-O-T-H. Who is the enemy of your silk and woolen cloth? It is the moth. Okay. So when you dye it with this one, moth, and the moth will not going to affect your cloth. Okay, not that. Then we'll go for sulfonation. Sulfonation is not being given in your book, but I will do it for you, huh? To show that how much I know. Huh? You have to, because for your entrance exam. Now the entrance exam has created such imbalance in your life. Huh? Sulfonation. So how it is done? Sulfuric. It is carried out by heating phenol with fuming. Moment you open the bottle, this vapor should come out. We call it fuming sulfuric acid. To give a mixture of ortho and para hydroxy benzene sulfonic acid. Ortho and para hydroxy benzene sulfonic acid. Okay? So I'll write it now. So I'll write in this way. You can control this reaction. This is phenol. If you do it low temperature, not low means that not that low, you'll find in that case ortho product is more. So we'll write now here. Fuming H2SO4 288 to 298 Kelvin. Okay, you get the ortho. You can control it. So you'll get here ortho hydroxy or 2-hydroxy benzene sulfonic acid. And if you do it at higher temperature, fuming H2SO4 373 Kelvin, okay, in that case you get 4-hydroxy benzene sulfonic acid. So it is 2-hydroxy benzene sulfonic acid, and it is 4-hydroxy benzene sulfonic acid. All right? Very good. Now we'll go for a very important one again for exam. This is not in your textbook, so your teachers are not going to ask this question on it. Okay? This is only for entrance. I told you, entrance is become a very painful part of your life. These are very near, especially for the boys. Because if they have to marry, they may also have to pass entrance exam. So in future, any boy proposes you people, first you ask that, did you clear entrance exam? Otherwise, same day turn them out. Such useless boys will be a botheration in your life. Okay? Then 4, Friedel-Crafts. Friedel-Crafts reaction. I think you remember what is Friedel-Crafts reaction? See, Friedel-Crafts reaction where we go for alkylation and acylation of aromatic ring with the in presence of Lewis acid catalyst like aluminum trichloride, boron trifluoride, chloride, and all these things. Clear? So, but you will find here that phenol has oxygen of phenol has 2 lone pairs. We know any electron-rich molecules are Lewis bases, and aluminum AlCl3 is a Lewis acid. So when you try to go for alkylation and acylation reaction, before the reaction takes place, Lewis acid catalyst AlCl3 and phenol they react within themselves. So in that case, the reaction does not occur. Okay? So please write down now whatever I say. Right. Very important. Put 1, 2, 3 star like that. Right. Normally, phenols do not undergo Friedel-Crafts reaction because the electron-rich phenol, sorry, do little correction, because the oxygen atom, sorry, the electron, sorry, because the electron-rich oxygen atom of phenol acts as Lewis base, Lewis, Lewis base, adds to
Pardon, sir?
adds to Lewis acid catalyst, put a comma and write AlCl3 and form an addition product, full stop. So we'll write this one. This one. See here, this is phenol. It has two lone pairs. And see here, AlCl3, it is electron deficient. So we'll write down here, Lewis base. And this is Lewis acid. We know acid and base react. So what you are going to get? You will get here see here. All right, this one attached. So what is this? One extra electron has come to aluminum, so it has become negative. So you will get here now H plus and Cl minus. So we'll write addition product. Addition product. This is very important. I'm telling for embossed is very important. It might come next year. How many embossed species are here? I think in this group only 3 or 4. Lavan is there, one son, Elizabeth, and Lisa. 4 of them. I don't know any other else are there. Embossed. Hey, Lavan, you are there in the group. Sajenne, Lavan? Huh? Lavan? No. I don't know how many of you are attending. I'm tuition bomb. Okay. See, if it is like this, I may stop sending videos. People are getting too lazy. And what about, oh, one more species is there. My manager, hey, Dishti, hello. I think she is taking back. Dishti? No problem. Okay, now we are coming for some very, very important reactions. Extremely important for both CBSE and MBOS. Okay, this is called Reimark-Tiemann. REI. Reimark-Tiemann. 100% chances they are going to come to exam. Reimark-Tiemann reaction. One of the most important. Okay, so what is this? When a mixture of phenol, chloroform, and an alkali. Okay, what is that? It can be sodium hydroxide or potassium hydroxide. Is heated, followed by acid, followed by neutralization. Give salicylaldehyde. What is his IPC name? 2-hydroxy benzaldehyde. Please start writing this one. I'll do the reaction. By this time, you will please write down this. And if you any word you don't understand, ask me. So see. So we'll write this one like this. I'll write with the doom. This. CHCl3. Then NaOH. We heat it. Okay? We'll get here O N A C H Cl 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 Cl. Okay? Then hydroxide is already there. So we'll take here now sodium hydroxide. We know this is a haloalkane. So always the chloride bromides are replaced by hydroxide. So what you are going to get here? You will get here O N A H. This step is not being given in your book. Okay, you will get this. This carbon, which contains 2 hydroxyl group, are extremely important because they repel each other. What is going to happen? See here. The molecule of water will be lost. What you get here now? You will get it like this. ONA, this. And water will go out. See, now we are going to neutralize it. So for neutralization, what will do? I will add acid. Once I add acid, then I will get here this. This is called salicylaldehyde or 2-hydroxy benzaldehyde. Very, very important. Ani layup. Clearly, silently hide. And to hydroxy.
So we can't see anymore.
Oh, after this much you can see.
So
Can you
to
see
the
this one? This
yes
one is
sir.
visible.
Yes sir.
Huh?
Yes sir.
Acha.
A bit.
Okay, later on I'll tell you. After that, no. Bottom you write this one. This one. Please write. Right. আমাদের সুন্দর হরিয়া রাখলাম আবার আচ্ছা আচ্ছা বলো দাম তো হলে অতুল বাকি উঠবো একটু ধরো দেন পাইপটা আরে বলো একটু ওখানে ধর আমার পাইপটা একটু টানতে লাগলো হয়ে গেছে বাস আনি দাও আচ্ছা শুনে রাইটিং hello
Yes, sir.
Now I'll do one more for entrance so there you can put entrance so here I'll change it so it is called carbon tetrachloride. Okay, it is the extension of Riemann reaction, but it is not being given. Okay, so it will give you salicylic acid, and it will be. This is only for your entry. I wish that all of you can do well. Situation is not good, no. Otherwise, at home, I would have taught you so much. CCl4. Cl. Here I'll write 3. Here I'll write here this. Okay? So anyway, I want to make it little simpler for you. Next step, I'll go for shortcut. See, everything goes nice, then next year, after your exam is over, at home I'm going to teach you. And don't worry. Even if you take admission in some coaching institute in Shillong also, I'll teach you separately. but if you feel I'm worthy of it, it's not a compulsion. I'll write here now sodium hydroxide, and 2 I'll write here HCl H2. You'll get this. This is for your interface. If you do chloroform, you get aldehyde, and if you take carbon tetrachloride, you get salicylic acid. Salicylic acid is used as medicine. It is having antifungal and antibacterial properties. Okay, any of your this type of cream, ointment that you use contains salicylic acid. Today I'll take little more time because I started late now. But anyway, I'm going to leave you at 8:45. Don't worry. Daniel is there. Daniel? Daniel? Hello, Daniel.
So I don't think he joined the class today.
Acha.
So we have a test, that's why.
Acha. Okay. Finished?
Yes,
Have you
sir.
finished again? Okay. Now we'll do one more reaction. This is called KOLB. In your book, only this is being given, but in entrance exam, they will give you that you will get confusion. Schmidt or Kolb's reaction. Okay. We'll write now. When carbon dioxide is passed through an alkaline solution of phenol. Okay, let me see the temperature. At 400 Kelvin, under 4 to 7 atmosphere pressure, followed by any alkaline reaction has to be neutralized. Neutralization gives salicylic, same acid we are preparing in other form. This is also important for exam. Okay. So right now here phenol, carbon dioxide, sodium hydroxide, 400 Kelvin and 4 to 7 atm. So what you'll get now here? You'll get here O and A, because you know phenol is acidic, carboxylic is also acidic, so they are going to form salt. Then I'll add here, I'll neutralize it by adding dilute acid. And what I'll get now? I'll get here. Salicylic acid. Salicylic acid. So I told you that salicylic acid is used as a medicine. So I'll do one more reaction. Right now here, acetylation. Acetylation of salicylic acid. When salicylic acid is heated with acetic anhydride, either in presence of small amount of concentrated H2SO4 or sodium acetate. Sodium acetate, you don't get scared. I will give you the formula COONA. Give 2 acetyl salicylic acid. It is being used as an analgesic drug. Analgesic drug means which reduces pain and swelling. Reduces pain and swelling under the name aspirin. You have already taken also aspirin. Okay, this is also important for exam. So I'm writing it here. This is our salicylic acid. Okay. Salicylic acid. And this is acetic anhydride. Acetic anhydride. What you have to add here? Either concentrated H2SO4 or sodium acetate. So what you are going to get? I think you can see COCH2 and this is this. So this is 2 acetyl salicylic acid. See, this group is called acetal. And its medicinal name is aspirin. Okay, up to this much is enough. So I think tomorrow I'll just talk to you a little bit extra for entrance. Then I'll go to ether. Thank you. Good day.
Thank you, sir. You too.
Thank you, sir.
Welcome,
Thank you,
dear.
sir.
Thank you, sir.
Welcome.